Hello students, good morning. I am Bhavyashree Bangale, MC Department, IISc Pune. Now in this video lecture, we are going to discuss about RTOS, features of RTOS, what are the characteristics belong to RTOS, what are some various applications and advantages of RTOS, that is a real-time operating system. Now I just start my presentation. I share a screen. Now, as we discussed in a previous video, what is a RTOS? So now RTOS means what? We can say that it is a system. It is said to be when it requires complete tasks and deliver a particular services on a time. That time we can call it as a real-time operating system. Means what? This system had set some time duration or having some deadline. So within a deadline of that time duration, that task must be completed, right? So this system having some features are there. So first is scheduling. Scheduling means what? This RTOS can based on the priority based scheduling. Means whatever the job and process are want to execution, so that job having some priority. So on the basis of that priority setting, it can be scheduled at the basis of priority. Now your second features is it can occupy a very less memory. When your RTO system, real-time system is used, so it can occupy the less memory. Why? Because whenever any event can set for execution and suppose that event didn't occur, so this system don't waste the time on particular event. Okay, so this can occupy the less memory. So now third feature is consume a fewer resources. It can consume the minimum resources for this system. Now it can take response time at the highly predictable. Means whenever any process want to execution, so within a quick response, this system can give the desired result for that. Now next feature is unpredictable environment, and last feature is the kernel save the state of interrupted tasks and then determine which tasks should be done next. So all this functionality can save with the help of kernel. It can save the state of that interrupted task, whether that state or that process want to execution, it is go for the running state. So this can be all determined by the kernel. Now some characteristics of RTOS. First characteristics is your time constraint. So time constraint is related to your real time system. Means it can be the have a time interval allocated to respond of an ongoing process. So this system have some time constraint, some time duration for allocated process or job. Then second characteristic is correctness. It provides the accurate correctness. It is one of the prominent part of real-time system, and this system provides the correct result within a given interval. So this system, the correctness of the result is obtained in a result in a time constraint. Now next characteristic is embedded. So now all your real-time system are embedded nowadays. This embedded system means a combination of hardware, software designed for a specific purpose. Like embedded system design a specific task to perform on a devices, not in a computer. So this system can collect a data from environment and pass this to the other component of the system for processing. Now your next characteristic is safety. So safety is also necessary for each and every system. So this is necessary for any system, but real-time system can provide critical safety when it can perform a long time without failure. It also recover very soon when the failures are occur in a system. It doesn't cause any harm to the data and information. So this type of safety can provide by RTOS. Now next characteristic is concurrency. In concurrency, real-time systems are concurrent. That means it can respond to the several number of processes at a time. There are the several different tasks going on within a system. It responds according to the every task in a short interval. Means each task having an interval set so that tasks and responding according to their intervals, and at that same time number of the process are going to for execution. So that features also provided by the RTO, that is a concurrency. Now next characteristic is distributed. So now in various real-time systems, all the components of system are connected in distributed way. Means the system is connected in such a way that your different components are at a different geographical location. And the last characteristics is your stability. Even when the load is very heavy, then your real-time system responds in a time constraint. So this system didn't delay the result of the task. Even there are the several tasks are going on a same time. Means it remains stable whenever load is very heavy. But at that same time, this system respond in a time constraint. Means each job and process having some constraint are there. So for that, this system does not delay the result of the task. So that's why it can provide the stability for that particular system. Now some factor affecting to the RTOS. Now first is your performance. So performance is the most important factor required to consider while selecting for RTOS. Why? Because every system important for the performance. Suppose we take one example like a scheduling. So in that scheduling, suppose there are the number of the process are on to execution, but suppose that process are not in a queue for execution, so it can take too much time for searching that particular job. So the obviously the performance will be decreases. Why? Because it can take the time for next execution. So performance is also important. Then middleware. In this RTOS, there is a no middleware support in your real-time system. Then the issue of time taken integration of processes occur. Then next is a error-free. This RTOS system are error-free. Therefore, there is a no chance to getting an error while performing the task, because it can provide the such a type that is a soft real-time operating system also. If any case any system are not execute or not performing the task on a time, so it can be smoothly delay that process but without affecting the result. Now next is embedded system uses. As we know, embedded system are in a small size, so it can widely use RTOS for embedded system. Maximum consumption, it can occupy or it can take a maximum consumption, achieve the maximum consumption with the help of the RTOs. That is, it can achieve the various resources. Now next is the task shifting. The shifting time of the task is very less, because whenever your job or event can be performed within a time constraint or that deadline, so shifting of that time of the task is very less, because all the jobs and the tasks are performed on a time because of the particular deadline and time duration. So now last feature is unique feature. So the good RTOS should be capable and it had some extra features like how to operate and execute the command, efficient the protection of memory and system. So these are some factors are affecting for the RTOS. Now next, some applications I listed here. So first application is industrial application. In your industrial area, this system is widely used. Why? Because this system has a vast and prominent role in the modern industry. The system made a real-time base so that the maximum and accurate output can be obtained. In order to such a things, real-time systems are used in a maximum industrial organization. So this system widely used in a industrial organization, and the system somehow lead to better performance and high productivity in a less time because it didn't delay some tasks or it doesn't switching the number of the tasks. Now some example of industrial application are automated car assembly plant and chemical plant. Second application is medical science application. In medical field also this system is widely used. It has a huge impact on human health and treatment also. There are various applications are there where the RTO system is used, that is the heart pacemaker also, MRI scan and radiation therapy. So in that medical science application also RTOS it is used. So due to this real time medical science may lives are saved and treatment of the complex disease has been turned down to easier way. So with the help of this system, number of the disease treatment of the disease can be down to easier way. People especially related to medical now they feel more relaxed due to this system because there are the various facilities are there in medical area for quickly MRI scan. It can treatment will be highly on a priority basis because some in emergency cases such a systems are very helpful to get a accurate result for that. The next application is peripheral equipment application. In that application, this system has a printing of the large banner and such as things very easier. This system made printing of large banners make a very easier. Now in this system came into the use and the technology become a more strong. The peripheral equipment are used for various purposes. Now this system are embedded with microchips and perform accurately in order to get a desired response. Means this system has a small in size, so RTOS can be used widely. It is used in an embedded system, so it can perform the accurately desired response. Some examples of peripheral equipment, that is a laser printer, fax machine, and digital camera. And the last application of the RTOS is telecommunication application. Now, with the help of this real-time system, map the world in such a way that it can be connected within a short time. So this system have enabled the whole world to connect via medium across a internet. So we are using this internet. Communication is very easy and we have to widely communicate with each other in whole world also. So that's why this system is also used in a telecommunication application. Some examples are there: video conferencing, cellular systems. And one of the application is there aerospace application. So this system also used in a aerospace area. Suppose most powerful use of real-time system, it is an aerospace application. It is basically hard real-time system are used in an aerospace application. Why? Because your hard real-time system can provide the time constraint. There is a no delay occur in your hard real-time system. So widely used this system in an aerospace application. Example for this application are satellite tracking system, flight simulation. Okay, so these are some examples are there. Then next, some advantages of real-time application. First is your maximum consumption. So it can provide the maximum utilization of a system for the output from the all resources. Then task shifting. If the time is assigned for a particular task, then the shifting of the task is very low because it can provide the time constant and deadline for that. Suppose for example, it can take about a 10 microsecond, then the shifting of one task to another, it can latest system, it can take a 3 microsecond. Okay. And the next advantage is focus on a application. So focus on running application and less important to the application that are in a queue. Means whatever the process or whatever the applications are in a running phase instead of the less important due to that application which are in a queue. Then real-time operating system in a embedded system. This size of the program is very small, so RTOS can also be a embedded system like a transport and others. It is obviously error free. This type of system are very error free. Memory allocation is best managed in this type of system. Memory allocation is there whenever any task and the process want to execution, it run or it can take care of the delay of that particular process. So memory allocation will be there for each and every process on a priority basis. And this system having some disadvantages, limited tasks, use heavy system resources and complex algorithms. Now, this system can uses very complex algorithm and difficult for the designer to write on. Why? Because it has some time constraint, having some deadline. Mostly important thing is that this system is a very less error free. In each and every task and job can perform on a time. So it can use a complex algorithms in that particular system. Now use a very heavy system resources. Sometimes the system resources are not so good, so they are expensive as well. Thank you, students.